Hey guys, this is Mr. Millings, and today we're going to learn about electromagnetic radiation and the electromagnetic spectrum. So what is electromagnetic radiation? Well, it says right here that electromagnetic radiation is energy consisting of tiny elementary particles called photons that travel in waves at the speed of light in a vacuum. So essentially, electromagnetic radiation is a form of energy that is made up of tiny little particles called photons and travels in waves. And light, the light that we see from the sun, for example, is one form of electromagnetic radiation. And the idea that light is both a particle and a wave is known as or is called the wave-particle duality of light. And we'll talk about this in a different video. You can click on that and see what that's all about. But basically, for now, just understand that electromagnetic radiation is a form of energy made up of tiny little particles called photons, and it travels in waves. And so if we take a look at the photoelectric effect, this is one little effect that shows us that light is actually made up of particles. If we beam this light, or light from the sun, for example, at a thin sheet of metal here, what ends up happening is that the electrons that are in the atoms that make up this metal here, they're going to jump off this metal, and you're going to have free-flowing electrons here that you can harness for electricity. This is essentially the idea behind solar energy and photovoltaic cells. The photoelectric effect is what's causing that. Okay, so this is one little concept or idea that allows us to understand that light is actually made up of particles. If we take a look over here, we have a prism, and what happens when you shine light through a prism is this: the light is going to slow down as it hits this more dense glass prism, and what ends up happening is that the light gets separated into these 7 colors that make it up: red, orange, yellow, green, blue, indigo, and violet. And violet has shorter waves than red, or wavelengths than red, so the violet light ends up slowing down more than the red light does, and this causes a refraction, right? It causes a bending of the light, so the light is actually going to come out over here instead of coming out over here, which might be what you think ends up happening. Okay, so a prism is one little model that shows us that light is actually made up of waves. So let's take a look now at the electromagnetic spectrum. Okay, so the electromagnetic spectrum is a range of all possible frequencies and wavelengths of electromagnetic radiation. Okay, the electromagnetic spectrum ranges from low frequency radio waves all the way to high frequency gamma rays. So what I recommend you do is pause this after I'm done talking and take a look at it and make sure that you fully understand what's going on here. But basically, the electromagnetic spectrum is a spectrum of all possible ranges of electromagnetic radiation. And on one end of the spectrum we have radio waves, which consist of very long wavelength, very low frequency waves, very low energy waves, all the way to gamma rays over here on the other end of the spectrum, which are high energy, high frequency, very short wavelength waves. And if we take a look in between, we have radio waves that come after microwaves that come after radio waves as far as increased frequency. Then we have infrared. Then we have the visible light spectrum, that is to say the light that comes from the sun, consisting of all 7 colors of the rainbow. And beyond violet, we're going to have ultraviolet, and then we have X-rays, which is another form of electromagnetic radiation. Okay, so these are the 7 forms of electromagnetic radiation. That is energy that's made up of tiny little particles called photons that travels in waves. And understand the concept that as you move this way, if you start with radio waves and you start to get smaller in wavelength moving this way, the frequency is going to increase and the energy in the photons are also going to increase. So if you're asked on a test which form of electromagnetic radiation has the highest frequency and highest energy photons, that's going to be gamma rays. And if you're asked on a test which form of electromagnetic radiation is going to have the lowest frequency and lowest energy photons, that's going to be radio waves. These radio waves have huge wavelengths, and that's going to make them have very low frequency, whereas over here gamma rays have very short wavelengths, as you see right here, and that's going to mean that they're going to have high frequencies. Alright, and that's because wavelength and frequency are inversely proportional. Okay, so these are the 7 forms of electromagnetic radiation. Let's take now a look at one form of electromagnetic radiation in particular, and let's talk about the visible light spectrum. That is the spectrum that our eyes can pick up on the electromagnetic spectrum. All right, so one form of electromagnetic radiation is called, or is the visible light spectrum. And if we take a look, visible light, that is to say light that comes from the sun, is actually made up of 7 colors. We have red, we have orange, we have yellow, we have green, we have blue, and indigo, and violet. Roy G. Biv, the 7 colors of the rainbow, right? And if we start taking a look at red, what we'll notice is that red has very long wavelengths. It has very very low frequency and very low energy photons. And as you move this way on our visible light spectrum, what we'll notice is that the wavelengths are going to get smaller. For example, if you take a look at orange compared to green, compared to blue, the wavelengths get smaller as you move this way on the visible light spectrum, and the frequency is going to increase, and the energy in their photons are also going to increase. So red is very low frequency, very long wavelengths and very low energy forms of the visible light spectrum, whereas violet over here, violet is very high frequency, it has high energy, and it has very short wavelengths. So understand this concept of the visible light spectrum and how it relates to wavelength and frequency and the energy of their photons. And if we take a look down here, we can see the different wavelengths of each color. For example, red is going to have wavelengths that are equal to about 665 nanometers, whereas green is going to have wavelengths that are equal to about 550 nanometers. And if we take a look at violet right here, you'll see that it has the shortest wavelengths and highest frequency. It has about 400 nanometers in wavelength right here. Okay, so understand the visible light spectrum and how it works. And so now what we can do is we can actually learn how to determine and calculate the frequency of a wave, the wavelength of a wave, and the wave speed of a wave. So let's take a look at how we can do that.